Okay, so we're going to talk about combinations and permutations. All right, so a permutation a permutation of n items is an ordered, very important word there, list of those items. Okay, the number of possible permutations of n items is given by this very special thing, n factorial. Okay, which is this thing. N factorial is equal to n times n minus 1 times n minus 2 times 3 times 2 times 1, all the way down to 1. You multiply. Okay, for n a positive integer and 0 factorial is equal to 1. Okay, so here's some examples. So example number 1, the number of permutations of 5 items is literally 5 factorial, which is 5 times 4 times 3 times 2 times 1, which is equal to 120. Okay, number 2, the number of ways 4 CDs can be played in a sequence is 4 factorial, which is 4 times 3 times 2 times 1, because we're doing it in a sequence. So as soon as you choose the first one, then that one's gone, and then you have 3 choices, and then you have 2, and then you have 1. Okay? All right. So now we want to talk about permutations of n items taken r at a time. Okay, so this is literally the formula P n r, which is equal to n factorial over n minus r factorial. Okay, so here's an example. The number of permutations of 6 items taken 2 at a time is this. Six factorial over 6 minus 2 factorial, which is equal to 6 times 5 times 4 factorial. You're going to see why we stopped at 4, because this is 4 factorial. These cancel, and you're left with 30. So there's 30 possible permutations when you take 6 items and you take it 2 at a time. All right. So now let's just do let's just do an example of like a computation. 10 permutations taken 2 at a time. This will be 10 factorial over 10 minus 2 factorial. So this is going to be 10 times 9 times 8 factorial, over 8 factorial. These will cancel, and then you'll be left with 90. Okay, so now we're going to talk about combination of n items taken r at a time. So this is the formula for this. C n r, which is equal to n factorial over r factorial n minus r factorial. All right, and with combinations, the difference between combinations and permutations is, this should be an r, is that combinations don't require an order, and permutations obviously do require an order. So example, the number of sets of 4 marbles chosen from 6 is, so this is going to be C of 6 comma 4. It's going to be 6 factorial over 4 factorial, 6 minus 4 factorial. We can see that I'm going to go up to 4 here. 4 factorial, and this will be 2 factorial. The 4's cancel. We know that 2 factorial is 2. So 6 times 5 over 2, which is equal to 30 over 2, which is equal to 15. Okay, so this is, let's write down one more thing. So a permutation requires order. Okay, so it requires an order if it has a term sequence, list, etc. They're talking about permutations. For combinations, a combination requires, does not require order. So let me fix that. Does not require order. So sets, etc. Okay, it'll be pretty blatant in the problem. All right, that's it.